Welcome, ladies and gentlemen. My name is Riani Barbarona. Today, I want to tell you about who am I and why am I making this video. I am a first college student at KTS with a course of Bachelor Secondary of Education, major in mathematics. Now, here's the thing that you need to know. Passion is something that drives us to keep us going as human beings. It is a basic human quality and we all have it inside us. So, if you're feeling frustrated about working on your math problems and stuff, just realize that you are a passionate person. You have got out there and embraced your passion and squashed the mathematics. The purpose of this tutorial is not just to help solve the problem, but to help students to become independent learners.
In this video, I want to show you how to derive the Pythagorean identities and double angle formula. So we're gonna be deriving the Pythagorean identities from the given red triangle. Label this one as A, this one is B, and the longest side of the triangle is C. So in Pythagorean theorem, we already know that C squared equals A squared plus B squared. Just divide both sides of the equation by C squared, and let's see what relation or identity we're gonna get. So cancel this out. C squared, so that is 1 equals, we factor this out by A over C raised to the squared, that is just equal to this, and plus B over C raised to the squared. So from the 6 trigonometric functions, only know that suppose this is our reference angle, which is theta, and this is 90 degrees. So this A is adjacent, this C is hypotenuse, and this B is opposite. So this A over C, so if this reference angle that is opposite side of the angle over the hypotenuse, so from the given 6 trigonometric functions, we have the sine theta equals to the opposite side over the hypotenuse, that is A over C. And we have also the cosine theta as adjacent over hypotenuse, so that is B over C. So we're going to substitute this one is equal to A over C, that is sine theta. Square plus B over C, that is cosine. So B is opposite and C is hypotenuse. So cosine theta squared. Simplifying, we have the relation 1 equals sine squared theta plus cos squared theta. So we have the relation that is 1 equals sine squared theta plus cos squared theta. So once again, from the Pythagorean theorem, C squared equals A squared plus B squared. So now let's divide both sides of the equation by A squared. And then from the given 6 trigonometric functions we have, so this is C over A, meaning that is hypotenuse over opposite side. So the C is hypotenuse, A is adjacent, and B is opposite. So from the given, we have cosecant theta equals hypotenuse over adjacent, that is C over A. Therefore, this is cosecant theta squared equals a squared over a squared, that is 1, plus b over a, that is opposite over adjacent. So that is cotangent theta equals b over a. So b over a, that is cotangent theta squared. Therefore, we have the relation cosecant squared theta equals 1 plus cotangent squared theta. So, we derive another identity. Again, from the Pythagorean theorem, c squared cos a squared plus b squared. Divide both sides of the equation by b squared. C over b, that is hypotenuse over opposite, that is secant theta c over b. So therefore, that is secant theta squared equals, so a over b, that is adjacent over opposite. So that is tangent theta equals a over b. So tangent theta squared, so plus b squared over b squared, that is 1. So therefore, we have another relation that secant squared theta equals tangent squared theta plus 1. So we have done deriving the Pythagorean identities. So let's have an example of double angle formulas. Find the value of sine 2 theta and cosine 2 theta if sine theta equals 6 over 10 and theta is between 0 and pi over 2. So the first thing we need to do is draw a right triangle and notice that theta is in quadrant 1. So 6 over 10, that is opposite over hypotenuse. Next, we should solve the adjacent of the right triangle. Then we use the Pythagorean theorem. A squared plus o squared equals h squared. So a squared plus, so the o is opposite, so that is 6 squared equals h is hypotenuse, that is 10 squared. A squared plus 6 times 6, that is 36 equals 10 times 10 equals 100. So a squared equals 100 minus 36. So a squared equals 100 minus 36, that is 64. Then find the square root of 64. So that is 8a equals 8. So the adjacent is 8. So the cosine alpha is 8 over 10. So because that is adjacent over hypotenuse. Now let's find the value of sine 2 theta equals 2 sine theta cos sine theta equals 2. So the sine theta is 6/10 times 6/10 and for cosine theta is 8/10 times 8/10 equals, so 2 is the same as 2/1 by the way. So we need to multiply. 6 times 2 is 12. 12 times 8 is 96. So equals 100 or 24/25. So to find the value of sine 2 theta equals, that is 24/25. Now let's find the value of cosine. So let's use the formula cosine. Cosine 2 theta equals cos squared theta minus sine squared theta equals, cosine theta is 8/10 squared minus our sine is 6/10 squared equals 8 times 8 is 64. And then 10 times 10 is 100 minus 6 times 6 is 36 over 10 times 10 is 100. So 64 minus 36, that is 28/100 or 7/25. So to find the value of cos 2 theta is equals 7/25. Next, let's have an example of real-world connection of trigonometric. A building 50 feet high. At a distance away from the building, an observer noticed that the angle of elevation to the top of building is 41 degrees. To the nearest foot, how far is the observer from the base of the building? Well, we're going to use trigonometry and we will draw a right triangle alongside the building. Now let's fill in the information that we have. The building is 50 feet high. The angle of elevation is 41 degrees. And the observer wants to know how far we are from the base at the building. So we had our opposite and our adjacent. So that is tangent. 41 degrees equals 50/x. Now we cross multiply and solve for x. That is 41 degrees equals 50. So x equals 50 over tangent 41 degrees. So our x is, that is 58. Which means the observer must be 58 feet from the base of the building.
Remember, when using those formulas, it's important to take account of the quadrant to which the angle belongs and to choose the appropriate sign. I hope you enjoyed this video. Again, just memorizing to being able to derive the formulas that we're using, especially in case like this, where they are relatively straightforward. Don't forget to subscribe if you haven't already. Thank you and have a great day.